Oh, it's just that one. Okay, so like I said, for spike times, the first variable was going to be minus 0.95. Okay, so that's this dot, and then we have a second minus 2.9 there. How do I have that? I do that by basically having this row vector of spike times replicated twice. Okay, so if you were to write this out, the first column of this matrix would be minus 0.95, and it would be another minus 0.95. Okay, now on the other side, what we have here, the first column will be 0, and the second one would be 1, because I said j is 1. Okay, so going back to my figure, so we can see that's exactly what happened. So we had a dot at minus 0.95, and it was, plotted at 0, and we had the same dot, and it was plotted at 1, and this plot function basically drew a line between them. Okay, so then the second column will be basically the second element of spike time, so it's minus 0.8, and we have a minus 0.8 at 0 and a minus 0.8 at 1, and there's a line drawn to that. Now when I selected this line and made it thicker, it didn't make the rest of the lines thicker, because these are actually lines that are, independent from each other. They're not connected in any way. And that is what MATLAB does. So if you give MATLAB a map this matrix versus this matrix, it will take the columns of those matrices and plot those matrices, on the figure. So in fact, these are all independent lines. So going back here, had I not forced this to be black, so K in MATLAB colors things black, you see I actually get a rainbow. Okay, and as pretty as that is very distracting, so we don't not want that. So by doing this, going back here, what we have achieved Okay, so what we have achieved is for the first trial of the direction 5, we were able to plot this first row. Okay, so now we need to draw the second row for this neuron. So what are we then interested in? So our j is going to be now 2, because we're moving on to the second trial in our chosen direction, which was 5. Okay, so now I have to go to direction and say, so find direction equal 5. Okay, so these are all the times that direction was 5. Oh, so it actually the trial after it was also for direction number 5. So that's trial number 3. Okay, for the overall experiment, but for the 5th direction, this is only the second trial. So j is 2, but my overall trial is 3. I need the overall trial because I need to know when that go cue was given. So that go is now something like 31 seconds. Okay, so let's go back here. Let's go back to spike times. Okay, spike time is neuron 1, find neuron 1, and so forth. Let me just remove this for a second and make sure that I am in fact getting values that are between 29 and 29.6 and 31.6. Okay, it's always good to check. And in fact I am, so I did things right. And again, this is a way to control things. Okay, when things don't work, the way you expect them to work, just try looking at it at a different angle. Think of what you know and how you can prove whether you're doing something right or wrong. Okay, and in this case now, by subtracting go trial, I am making it between minus 1 and 1 again. Okay, so let's leave it that way. Now spike times is a row vector, and it only spiked 12 times this time. Okay, so now how do I plot this, not on top of this, but on the row above? First of all, I need to make sure I don't lose that plot, so I type hold on, and let's see, we need to get back to this line. Like I said, j needs to be 2 now. This is something that would be in the for loop, so you don't have to hard code it all the time. So when j is 2 now, this 1 times will be multiplied by 1, and this 1 vector will be multiplied by 2. Okay, and voila. In fact, we basically were able to draw it on the row on top of it. Okay. So this is how to make just one of these raster plots for a given direction. Now, the goal is to be able to put these in places that they're going to be relevant. Okay? And in MATLAB, the way to do this is a subplot. Okay, so you can do a 3x3 subplot, but you can't just go and put direction 1 here because the experiment defined direction 1 to be here. Okay, so let's say you basically have a 3x3 matrix. Okay, and MATLAB actually starts counting, so there's our 3x3 matrix, starts counting these, I guess boxes or entries as, it counts them in rows. So this would be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so I want to be able to put direction number 1 in spot number 6, direction 8 in spot number 9, and 1, 2, 3, 4, and the 4th direction needs to be in spot 1. Okay, so I gave you another hint on how doing this. So I created this new variable called graph, and it basically puts for all of the 8 directions where that raster plot for that direction needs to be plotted. For instance, the first entry is 6. That's because I want the first direction to be in spot 1, 2, 3, 4, 5, 6. For instance, spot 5 is going to be empty, so there's basically no 5 in this vector. Okay, and I actually put this arrow figure myself after I generated this in MATLAB, so I did not do this in MATLAB. I've been getting questions on how to do that in MATLAB, and that is actually not something that I did with MATLAB. It was basically a post-processing of that figure. Okay, so if you basically were able to do this for one direction, you were able to do it for all directions. Okay. Let me, for just storage sake, stop this recording now, and I will continue with another one.